All right, ladies and gentlemen, today we are starting a brand new unit on systems of linear equations. It's actually a really cool thing you can do with linear functions, and it has a lot of applications in the real world. What I'd like you to do is on the guided notes that I gave you, on the first page at the top, please put January 21st, 2014, and we are going to start over at page number 1. Okay, so please make sure you label the page number 1. Our objective is I can solve systems of equations by graphing each equation and then finding the intersection of the two graphs. With this new way of doing notes, with everybody getting the guided notes, I want you to really focus not just on writing the notes, but since you won't have quite so much to write, I want you to really concentrate on trying to understand the meaning behind the notes. Do not rush through this and try and get it done as quickly as you can. This isn't about simply writing the words down. It's about writing the words down and trying to understand them. Okay, guys, that's very important. So a couple vocabulary things we need to get out of the way. First, we need to know what an intersect or an intersection is. An intersection is when two things cross each other. You know that when roads cross each other, it is an intersection of two roads. You can also have an intersection of two lines. Also, we need to know what a system of equations is in the first place before we can solve them. So when you have two or more equations and you solve them together to find a common coordinate point. For example, let's say I have one graph that looks like this and one graph that looks like this. This point right here would be the solution to the system of equations, the point at the intersection of the two lines. With these notes, the way that we're doing them now, I want you also to concentrate on not just writing the words to fill in the blanks, but putting little things like this. You know, extra things that I write that might help you understand the notes. That's really important. I'm going to be looking for that when I check your notes at the end of each quarter. So now let's look at solving systems. There's lots of different ways to solve systems of equations. We're going to learn 3 in this class, and the first is solving by graphing. This is probably the most simple way to solve equations, but it's not always the most accurate. All right, so down here I want you to write most simple, not the most accurate. So if you are, let's say, working at a business, you are the CEO of a company. Whoa, I can't spell. And you really need to find out at what point you break even. So when your profits are more than your expenses. So, sorry, revenues more than your expenses. I really can't spell. There we go. You would need to have a very accurate number, so you would not want to solve a system by graphing. But it can be useful for more informal things. So what you're going to do is you're going to graph each equation on the same coordinate grid, the same XY axis. And then you're just going to find the point where the two lines cross. That's it. That point of intersection will be the ordered pair, so it's going to be something like perhaps 3, 1, that makes both equations true. There's a really nice way that we can check our work when we're done to make sure that we solve these things correctly, and I'll show you that. So let's go through our first example. We have y equals 2x plus 4 and y equals negative 2x. First thing we need to do is graph them. And in order to graph them, I need you guys to make an XY table. That's the best way to graph them. Let's think back to what we did a few months ago. An XY table, I suggest you use at least 3 points. I like using -1, 0, and 1. They're nice and simple. Almost always work out pretty well. If I plug -1 into here, it's going to be 2 times -1 plus 4. 2 times -1 is -2, plus 4 is 2. I can do the same thing with all of my other points. 2 times 1 plus 4 equals 6. I want you to show this work, guys. So this right here is our y value for these x values. Let's do the same thing for my other equation. I'm going to do -1, so that's -2 times -1 gives me +2. -2 times 0 equals 0. Negative 2 times 1 equals negative 2. And those are my y coordinates right there. All right, so we've made our XY table. Make sure you've written all of that down. And now we have to go on and actually graph them. So I have my XY chart right here, and I'm just going to be going back and forth between my screens to plot my coordinate points. So first I have -1 for my X and 2 for my Y. So -1 goes left 1, up 2 for my Y. There's my first dot. I have 0, 4 over 0, up 4. And I have 1, 6. Let's go and plot that over 1, up 6. Once I've plotted the points for that line, I can take a straight line through those points. Use a straight edge, guys. Do not try and do this freehand. You will not get it correct. So that is my first linear equation. All right, so then all we have to do next is just graph our other line. So we have different points. I'm going to do these in a different color to make it a little easier. I'm going to do blue. We have -1, 2. So I go left 1 and then up 2. Oh, look at that. That matches up with a point on the other line. That might be our intersection, but let's keep going just to double check. We have 0, 0 right there. Remember, when we're graphing linear equations, if it's not a straight line, you have done something wrong. It's probably something wrong in this step here where you're making your XY tables. So if you look, I've graphed all of those points. You should have done the same thing on your paper. I will now connect these in a lovely straight line, and I will try to identify my point of intersection. In this case, it was really easy. It just happened to be one of the points that actually was in our XY table. It's right here at the point -1, 2. That right there, ladies and gentlemen, is the point, the ordered pair that makes both of these lines true. So if we're going to actually check our solution we said was -1, 2. That's our ordered pair. In order to check it, we have to plug it back into each equation. Write all of this down. So my y is 2, I'll write that just below my y, equals 2 times x, which is -1, plus 4. So then I have 2 equals 2 times -1 is -2, plus 4, which gives me 2 equals 2. That checks out. So we know that this ordered pair is a solution to my first equation, but I also have to check my second equation. Once again, my y is 2, so I'll plug that in. And then I have -2 times x, which is -1. All right, so let's go ahead and simplify that. -2 times -1 is +2. That checks out. And I'm very happy because now I know that this is the solution to my system of linear equations. All right? So I am going to give you a reflection question in just a moment. So just hang on and I'll pop it up there in just a minute. All right, guys, so this is your reflection question. It's on the notes that I gave you. Your first equation is y equals 3x minus 2 and y equals -x plus 6. And I gave you graph, a coordinate plane. Please make sure that you check your solution to the system of equations, or else you will not get full credit. I will be checking this in class tomorrow, but I would like you to type in the ordered pair that you found as the solution into Edmodo. All right? Thanks, guys. Have a good night.